In this set of videos, we're going to take a look at creating a Gatling gun turret that points towards our mouse position and follow through with creating a decal system for our bullet holes and optimizing it through the use of object pooling. Coming up. Hey guys, I'm John with GameDevHQ, and every week we bring you 3 amazing pieces of content related to all things game development. On this channel, our goal is training professional game developers. Hit that like button and subscribe, and check us out at GameDevHQ.com. So here we are in Unity. I have a Gatling gun from GameDevHQ's file base, and if I left click, it's automatically going to fire, and we have some particle effects coming out. The goal here, though, is that the Gatling gun is going to follow my mouse position, and I'll also have a crosshair that's following my cursor, basically, or turning my cursor into a crosshair. So let's do the crosshair first. So to get started with the crosshair, we need to display a crosshair as an image component. So to do that, you'll see here I have a crosshair image, and I want to basically overlay it on my screen and have it follow the mouse position. To do that, we're going to go to Create in the Hierarchy, UI, and we'll create an image component. This is going to allow us to drag the crosshair into the image source. We'll rename this game object to crosshair, and I'm just going to take my crosshair and drag it into the source image. Now, if you're dragging in an image for your crosshair and you can't drag this directly into the source image, it's because the texture type is probably set to 3D or default. If that's the case, you need to select the texture type and change it to Sprite 2D in UI so that we can make use of it within our canvas. Once you're ready, hit apply, and then you'll be able to just drag and drop it into the source image. So here's our crosshair. And what we want to do now is position the X value to 0 and Y and Z. So here we are, it's on the screen. I want to preserve the aspect ratio, and I'm going to set the native size. By doing this, it's going to ensure it's its full size. And then here, right now it's a little big, but one of the things I want to make sure that happens here is as I scale my game, my crosshair scales with it. And you'll see here that that's not the case. To fix this, we can select our canvas and we can change the scalar mode or the canvas scalar from constant pixel size to scale with screen size. By doing that, our crosshair will now scale proportionately. So really easy. Now that we have our crosshair here, we need to make it follow our mouse. So in order to do this, we need to create a new script that's going to control the crosshair. And the logic here is that as I run it, I just want the position of the crosshair to match my position on the game. Well, lucky for us, we can easily access our mouse position through the input manager. So let's create a new C# script by going to create C# script, and let's call this crosshair. I'm going to select the crosshair game object in my canvas and attach the crosshair script. Let's open this in Visual Studio by double-clicking, and all we want this script to do is basically handle the behavior of saying, hey, you need to match where the player's mouse position is. So to do that, we're just going to use void update, and within here, all I'm going to say is I want to take the position of this crosshair, which can be accessed through transform.position, and it needs to equal my mouse position. So to do that, I simply just type the input manager, or input.mouse position. And you'll see here as our tooltip highlights the current mouse position and pixel coordinates, and we can get that information. By saving this, we should be able to then move our mouse and have our crosshair follow through with it. You'll see here if I run the application, we're now moving our crosshair. The problem though is that I can see my white crosshair. I want to create logic now that's going to hide this on start, and if I hit the escape key, bring it back so that I can stop the editor. So to do that, we'll go back into Visual Studio, and we're going to create a void start to initialize this behavior. In void start, we need to basically just access the cursor, which we can do so using the cursor keyword. From there, there's a visible property, which we can just simply set to false. The logic that we need to now create, however, is that if I hit the escape key, I need to make sure that my cursor becomes visible again. In pseudocode, that looks like this. If escape key, then we want to say cursor visible equals true. So how do we get the input for the escape key? Well, we can use a simple if statement. We'll use the input class to gain access to the getKeyDown is what we're looking for. So input.getKeyDown. And then by opening up a parenthesis here, you'll see here that the tooltip is looking for a key code. I can type key code dot, and then here any key code that's available on my keyboard. So I want the A key, I can use A. If I want the G key, I can use the G key. Or if I want the escape key, I can use the escape key. So our program is going to check for the escape key press, and it's going to get key down. So when I press it down, and if that's the case, what do I need to do? I need to access our cursor and set the visibility to true. And that's going to work just fine. Let's save this, test out our script. And you'll see here that as I move it, we have no cursor. And if I hit the escape key, we now have a cursor. Now what we need to do is have our Gatling gun rotate and point towards our mouse position. So let's check out how to do that. The first thing that I need to do here is I need to look at my Gatling gun and figure out which object are we going to be rotating. The object that we're going to rotate here is called minigun base. And if I look at this, I can basically rotate this guy along the x-axis just to move it up and down, as well as the y-axis. And that's exactly what we need to do. We basically need to calculate a direction for him to point based on where our mouse is in the world space. Now we have this wall in front of us, so what I want to do is I want to create basically a raycast from our mouse position, and then use that information to calculate a vector for our turret to rotate towards. So to get started here, let's create a mouse look script. So here in our C# script, we'll create a look at mouse. So look at mouse, and we'll attach this to the main camera. Let's open that in Visual Studio, and let's take a look at what we need to do here. The first thing that we need to do is I need to know what I'm hitting. I basically need to cast a raycast from my mouse position onto this wall here, and I want my turret to follow through and look at it. So in order to cast a ray from our mouse position, we can do so by creating a ray origin and assigning it to the main camera, and there's a method called screen point to ray, which will allow us to basically put in a mouse position, and it will take your mouse position coordinates on screen space and cast them into the physical world, and if there's a collider there, then it will return information about what you hit. Now, raycasting can seem pretty scary at first, but I promise you it's actually pretty easy to work with. One of the things we're going to be doing here is, because we're working with physics, is we're going to use fixed update. And the first start of getting into raycasting is to create what's called a raycast, or a ray. This is going to be a 3D line that can detect intersecting points in 3D space. And what we're going to do here is we're going to give this ray a variable name called ray origin. And we're going to assign the ray origin to our mouse position. To do that, we need to access the camera, which is our main camera, and there's a method here called screen point to ray. If we open up our parentheses, it says returns a ray going from the camera through a screen point. Our screen point is basically the center space, or where our crosshair is. That's where we want to cast a ray into the physical world. So to do that, we then have to pass in a vector3 coordinate pose. Well, that's our input.mouse position. So here, input.mouse position. Now that we have our ray origin, what we want to do now is cast the ray. To cast the ray, we put it inside an if statement. If we hit something, then we can run some logic. Inside of here, we can say if physics.raycast, and what it's looking for here is one of 16 options. We can just cast a ray, but I need to know information about where we hit. It's going to be important later when we create a decal system, but also I need to be able to calculate a vector on where my turret should look at. I need to look at some point on the wall that our mouse is detecting. So to do that, we need to basically output information to know what my raycast hit. So the option here that we're going to look for, if I open up the parentheses here, is option 3 of 16, where it takes in a ray origin, and then it basically outputs information about whatever our raycast hit into a raycast hit variable called hitInfo. So to do that, I need another variable here called raycast hit, and we're going to call this hitInfo. Anything my raycast hits in the physical world is going to be stored inside of this raycast hitInfo variable. To actually cast the ray now, we can basically say if physics.raycast, we're going to cast from the ray origin, which is our mouse position, and we're going to output whatever information we hit into the hitInfo variable using the out keyword. From there, it's best practice to always null check what you hit before doing an operation with Raycast. So here, I'm just simply going to check if what we hit is null. So here, if hitInfo.collider is not equal null, that means that we actually hit something with a collider and we can point and shoot at it. And if that's the case, what we need to do here is we need to now calculate a direction of what we hit and then look at that object. So let's focus on actually looking at the object, and then we'll calculate the direction. To actually rotate towards that object, we need a reference to that turret barrel. So to do that, I'm going to create here a private variable that's going to store the transform of our turret barrel. So private transform, and we'll say turret barrel. And then I want to be able to assign it in the inspector, so we're going to use a serialized field attribute. You may be wondering why this is a private variable. It's private because I only want this script to be able to manipulate this turret barrel. I don't want the possibility of another script being able to reassign the value of this. So I'm going to go back to Unity, select the main camera, let it compile, and we're going to now drag in our Gatling gun minigun base, which is the part that's going to rotate. Just drag it in there, and now we have a reference to it. The next thing I want to do here is if we're hitting the wall, I basically want to tell my turret to, hey, go ahead and point at the wall. So to do that, I'm going to access the turret barrel dot rotation and set it equal to a quaternion dot look rotation. This is a method that's going to allow us to basically pass in a vector, and it's going to then point at that vector. So here, you'll see here, creates a rotation with the specified forward and upwards direction, or the direction to look in, which is your forward. So it creates a rotation with the specified forward direction. All right, so our forward direction here, I could say, hey, just look at hitInfo.point. So I'm gonna access the object we hit, and I'm gonna get the exact point of our crosshair, which is .point. That's gonna return a vector 3 and pass it in here. Now let's save this and check out the behavior. Let Unity compile, we'll run this application, and you'll see here that our gun is going to follow through with our mouse, and everything actually looks pretty good. But watch what happens if I fire. You'll see here that it's not going through the direct center of my crosshair. And the reason for this is because we're actually not calculating properly the forward direction to face. And that comes down to a simple bit of mathematics. How do we calculate direction? Well, the formula for calculating direction is direction, which is a vector, equals the destination minus the source. The destination is our hitInfo.point, and the source is our turret. So the way we can do this here is we can create a variable to calculate the direction. So vector3 direction equals the destination, which is our Raycast hitInfo. So we're going to say hitInfo.point minus the source, which is the turret barrel. So here I'm going to say minus the turret barrel dot position. By saving this, we can then hop into this little parameter here, and we're going to pass in the forward direction to face, which is that vector. That vector calculation is going to draw a line from the center of our crosshair to that turret barrel and say, look here, or align yourself with this. Now, if we run this again, let Unity compile, you'll see here that everything is working as usual. And if I actually fire, it's now going towards the direct center of our crosshair. Thanks to all of our awesome Plus and Professional members who make this weekly content available. Special thanks to Laurie DK, Lucky Ducky 10, OJ Zach, and 6. You guys rock. I'll see you next week.